Welcome back. My name is Mr. Monty, and we're starting Lesson 4 in our 2020 series. 20 lessons of 20 minutes a day for 20 days in preparation for the college placement exam here at the community colleges in Spokane. Lesson 4 is a continuation of domain and range. It's stated, I can, given a function, tell what the domain and range for this function are. So, I like to come up with a 3-column data table where I can perform the operation of the function to come up with our outputs, our y values. We can find 4 or 5 coordinate points, sketch the shape of that curve, and then answer some specific questions. Now remember, before you take one of these exams, check with either your teacher or the college where you're taking it to find out what kind of a calculator you're allowed to use. Here in Spokane, for the placement test, we're only allowed to use up to a TI-30 type calculator, which means there's no graphing functions. So you have to be able to sketch some sort of a shape in order to answer the questions. At least I do. It really helps out. So let's get started here. We picked 4 or 5, in this case 5 arbitrary values to put into our function so that we can get an idea of what the shape looks like. The first value I'm going to use is -3, and I'm going to plug it in for the x value. So, minus a -3. Wow, that can be confusing. Minus a -3 squared, -3. I think they're trying to trip us up here. -3 times -3 is 9, and it's a minus. So it's -9 minus 3 gives us a -12. So our first coordinate point is going to be -3, -12. Now remember, you have a calculator. If that's confusing to you, either write it all out or type it into your calculator using the brackets, the parentheses, so that we make sure we get all our minus signs correct. Let's do that one more time. Minus a -3 times a -3 minus 3. Yep. -3 times -3 is +9, so -9, because there's still a minus, -3 equals the -12. Yep. Let's try the next one. Minus a -1 squared minus 3. -1 times -1 is a 1. There's still a minus, so -1 minus 3 gives us -4. So we're going to have -1 -4. The next value, 0. Minus a 0 squared minus 3. 0 times 0 is 0. 0 minus 3 gives us a -3. So our point will be 0 minus 3. Then we finally get to some positive numbers. A positive. So minus a +1 squared minus 3. So that's 1 times 1 is 1. So -1 minus 3 gives us a -4. So that point will be 1, -4. And our last value. Let's plug in a +3. So minus a +3 squared minus 3. 3 times 3 is 9. So -9 minus 3 gives us a -12. Our final coordinate point will be 3, -12. Let's take these 5 points and see what kind of a shape we end up with. So we have a -3, -12. Be about right there. -1, -4, all right there. 0, 3. 0 minus 3. There's our y-intercept. And 1, 4, 1 minus 4, point, and 3 minus 12. 3 minus 12. Let's connect the dots. Let's see what our shape looks like. Now remember, given a function with no restrictions, I make sure I put arrows at the ends so that we remember that it goes on forever into infinity. Let's answer some specific questions before we get to the final answer here. Family of functions. Let's look at the original function, and we see that we have the variable x raised to a power. So there's our first answer. This is a power function. And because it's to the second power, we can remember that it's a quadratic. In our math background, do we remember what this shape looks like? An upside down smiley face or a U? We can call that a parabola. Y-intercept. I want to make sure that we're in the habit of always labeling our y-intercept. That'll come in handy. Y-intercept, in this case, was 0, minus 3. So 0, minus 3. Okay, now I think we're in a position where we can actually answer domain and range for this function. Domain refers to all the possible x's, the inputs that I can stick into this function. Well, if we want to look at that, we say all the x's in the negative direction, all the x's in the positive direction. Well, if this goes on forever, we can say that we can put big numbers in here and really small numbers. So the answer here is all real numbers. Or in math terms, really small ones, so minus infinity, less than or equal to x, which is less than or equal to positive infinity. Now the range, a little bit more difficult, the range. What are the y values that we get out of this function? It can be a little bit trickier, but let's look at the really small x's first. If I put a really small one, minus infinity, we see that this minus always kept it minus. So when I come way out to the minus x, I get a really big minus y value. So we do get minus infinity. That exists. How about when I put a really big number in here? When I put a big positive number, the bigger the x, I get really small y's. So both sides are approaching this minus infinity. I don't ever get anything up here though. Let's put a little dotted line right here. Something happens at minus 3. I get values that are always less than minus 3, and I get minus 3. So the biggest number I get, the biggest number that I can possibly get as an output is minus 3. So the y's have to be less than or equal to minus 3 that exists down in here. Yep, minus infinity. So from minus infinity way down low all the way up to and equal to minus 3 is our final answer. Always check with your teacher or professor or what the proper answer and notation would be. Because some folks don't like just all real numbers. They want actual math terms written out. So, our original goal, domain and range, are I can write the domain and range for a given function. And we did that. It took some steps in order to get our shape, but our final answer was I can write the domain and range for this given function. And in this case, the domain was all real numbers. Really small minus x's to the really big positive x's. In our range, nothing exists up here for our output, but it starts at minus 3 and below. So from minus infinity, less than or equal to y, less than or equal to minus 3. This concludes Lesson 4 in the 2020 series. See you next time for Lesson 5.